press the bell icon on the YouTube app and never miss another update.
Hello students, in the last class we discussed quotient rule and product rule, yes, na, with respect to their problems. Today we continue the same topic. So we write, find the same question I written here, find the derivatives. Find the derivatives of the following functions. Find the derivatives of the following functions. I continue. Miscellaneous, what we discussed in the last class, miscellaneous problems. So we continue. Okay. So under that, the next problem is y is equal to x plus cos x into x minus tan x. Observe the problem, x plus cos x. In the last class I written f of x. Today I written y, no problem. If I written f of x, the derivative is f dash of x. If I write y, the derivative is dy by dx. That is the only difference. So observe here this problem. This is the first function and this should be the second function. Which rule you applied here? Product rule. Okay. So we write the sentence, differentiate with respect to x. So y with respect to x, we write dy by dx. X plus cos x, first function into, everyone know this one, first function into x plus cos x into d by dx of x minus tan x plus x minus tan x into d by dx of x plus cos x. First function into, you know everything, derivative of second function plus second function into derivative of first function. Okay. So that is equal to, observe this problem, you also solve x plus cos x. Derivative of x is 1. Yes, na? Derivative of x is 1 minus derivative of tan x, secant square x. Derivative of tan x is secant square x plus x minus tan x, derivative of x is 1, derivative of cos x is minus sin x, minus into plus minus sin x. I think this is enough, this problem, it is enough. No need to simplify this one. So I think you perfect about product rule and quotient rule, then only you can solve any type of problems. Firstly, you understand the concept, that is very important. If you know the concept very well, you can solve any type of problems. If you not perfect the concept, then it is very difficult. Observe here, this differentiation concept, it is a very important topic for both first PUC, second PUC, even including physics also. Okay, the next problem. Next problem, next one, y is equal to 4x plus 5 into sin x divided by 3x plus 7 into cos x. 3x plus 7 into cos x. So which rule applied here? Quotient rule, division rule. Yes. So write it. Differentiate with respect to x. Differentiate with respect to x. Y with respect to x, we write dy by dx. Quotient rule you know very well. 3x plus 7 cos x whole square. Correct. 3x plus 7 cos x whole square. Denominator square. Denominator into means 3x plus 7 cos x. Denominator into d by dx of 4x plus 5 sin x. Denominator into derivative of numerator. Minus 4x plus 5 sin x into d by dx of 3x plus 7 cos x. Correct. 3x plus 7 cos x. 3x plus 7 cos x whole square. We read as it is. 3x plus 7 cos x into. Observe here. For constant into function. 4 I write as it is. Derivative of x is 1. Plus 5 I write as it is. Constant into function. Derivative of sin x is cos x. 4 into 1 is 4. Minus 4x plus 5 sin x. 4x plus 5 sin x we write as it is. What we discuss here, same concept. 3 into derivative of x is 1 because constant into function. Plus I write 7 into derivative of cos x minus sin x. If you want to multiply here, plus into minus what? Minus. I think it is enough. For this problem it is enough. No need to simplify it. If you want, you can simplify it. Okay, you can simplify it. Constant one side, function into variable one side, and cos x and sin x one side if you want. So for me it is enough. The next problem. Next one. Y is equal to x square cos pi by 4 sin x. X square into cos pi by 4 by sin x. How to solve this one, sir? Y is equal to x square. Pi by 4, you know, in the trigonometry, pi by 4 is a 45 degree, cos 45 degree also you know, 1 divided by root 2 sin x. So then we differentiate this, with respect to x. Y with respect to x, dy by dx. Sin square x, sin x into d by dx of, correct, 1 by root 2 into x square, 1 by root 2 into x square, minus, if you want you write 1 by root 2 outside also, no problem, okay, 1 by root 2 into x square, d by dx of sin x, d by dx of what? Sin x. Sin x into 1 by root 2 x square minus 1 by root 2 into x square d by dx of sin x. Okay, fine. So that is equal to sin square x sin x into, observe carefully very here, sin x into, that's 1 by root 2 constant that I write as it is, because observe here it is constant into function. First rule, constant 1 by root 2 we write as it is. Derivative of x square is what? 2x. Correct? N into x to the power n minus 1 minus 1 by root 2 into x square. We write as it is. 1 by root 2 into x square. Derivative of sin x cos x. I think this is enough. For this problem, it is enough. Why we solve these type of problems? Because we perfect the concept. Okay, for that purpose only I solved such type of problems. Next problem. Next one. Y is equal to x divided by 1 plus tan x. Very simple problem. Y is equal to what? X divided by 1 plus tan x. And differentiate with respect to x. Differentiate with respect to x. dy by dx. dy by dx. Denominator square. 1 plus tan x whole square. 1 plus tan x into d by dx of x minus x into d by dx of 1 plus tan x. d by dx of 1 plus tan x. 1 plus tan x whole square. 1 plus tan x into derivative of x is what? 1 minus x into, observe here, observe this derivative. Derivative of constant is 0 plus derivative of 1, that is a constant. Derivative of constant is 0 plus, because addition rule we apply here. Derivative of tan x is secant square x. I think you understand. So if you want 1 into 1, 1 plus tan x minus x into secant square x whole divided by 1 plus tan x whole square. 1 plus tan x whole square. Understand? Next problem. Y is equal to x plus secant x into x minus tan x. X plus secant x into x minus tan x. Product rule. This is the first function. This is the second function. So differentiate with respect to x. Y with respect to x is dy by dx. X plus secant x, first function into, correct? First function into d by dx of x minus tan x plus x minus tan x, second function into d by dx of x plus secant x. Second function into derivative of first function x plus secant x. This type of problem already we discussed. Derivative of x is 1 minus, we write derivative of tan x is what? Secant square x. Subtraction rule. Derivative of x is 1. So write the minus as it is, and the derivative of tan x is secant square x plus x minus tan x into, again here we addition rule, derivative of x is 1 plus secant x, derivative of secant x is secant x into tan x, secant x into what? Tan x. That is enough, I think, no need to simplify it. Okay, next problem. So next one, once again I write the headline, find the, why? Because there are different problems. Find the derivative of the following functions. Up to this we discuss only the trigonometric functions. We will see next different type of problems are there. Under that, the first problem, y is equal to x plus a, where a is a constant, y is equal to x plus a. Very simple problem, correct na? So differentiate with respect to x, y with respect to x is dy by dx, derivative of x is 1 plus derivative of constant is 0. So dy by dx is 1. Dy by dx is 1. Very simple problem. Next problem. Second one. Y is equal to px plus q int r divided by x plus s, where, one more very important here, where p, q, r and s are constants. P, Q, R and S are constants. Then how to solve this one, sir? Using product rule. This is first function, this is second function. No need to write like this. For purpose of understanding, I write here. Okay, no need to write in the examination. So differentiate with respect to x. Y with respect to x, dy by dx. Y with respect to x is dy by dx. Okay. Px plus q, first function into px plus q into d by dx of, I shift in 1 by x from denominator to numerator, it becomes x to the power minus 1. So 1 by x, I shift from x denominator to numerator, the power become what? Negative, plus s. Okay, here only I shift plus. Second function, that I x in as it is into r by x plus s into d by dx of px plus q. P, here it is no problem, because here we are not doing derivative, here we are doing derivative. So you know already derivative of 1 by x is minus 1 by x square. If you don't know, then we shift the x from denominator to the numerator, the power become negative. Px plus q. Oh, sorry, here constant into function, correct? Constant into function. We write the constant as it is, r x to the power n into x to the power n minus 1, minus 1 into x to the power minus 2. This function is over. This is over. Constant into function plus p, q or s are the constant, correct? Plus yes, only constant is present. Only constant is present. That means derivative of constant is what? 0. Got my point? Derivative of constant is 0 plus. So r by x plus s, r by x plus s. Observe here also constant into function p as it is derivative of x is 1. Derivative of x is 1. p, q or s are the constant plus derivative of constant 0. px plus q minus r divided by shift x to the power minus 2 from numerator to denominator, it becomes x square plus r by x plus s into p. That is enough. Here it is enough. No need to continue. Okay, observe this problem. This type of problems are very important, very important. Okay, next problem. Y is equal to ax plus b cx plus d whole square. Ax plus b into cx plus d whole square. Correct? See, observe here. Where a, b, c, d are the constants. A, b and d. A, B, C, D are the constants. Okay. Differentiate with respect to, sorry, because A, Cx plus D whole square. Firstly, better to we expand that one. Okay. So, one more method is there, composite function. But you know in the second PUC, presently we don't know about the composite function concept. For that purpose, I expand this one before going to differentiate. Y is equal to, it is in the form of a plus b whole square, c square x square plus d square plus 2c dx 2ab. Correct? I rewrite. Then this is what? The first function. This is what? The second function. Okay, first function and second function. If you want, you multiply also. In that, no need to apply the product rule. Okay, so presently we well know about the product rule. That's why we apply the product rule. Okay, if you don't know the concept of product rule, then what we will do, sir? You multiply ax to these terms and b to this term. Then we got an polynomial expressions, polynomial function, then we differentiate. In this method also we do it, but something what we very well know about the product rule, then we apply the product rule. Differentiate with respect to x. Y with respect to x, that you know, dy by dx, ax plus b d by dx of c square x square d square 2cdx 2cdx plus c square x square plus d square plus 2cdx into d by dx of ax plus b, d by dx of what? Ax plus b. Ax plus b into c square is a constant. So for this purpose, for this term, we neglect all this thing. Only we concentrate on this term, constant into function. C square is a constant. So okay, derivative of x square is 2x. Rule of 1. C square is a constant. We write as it is. Derivative of x square, n into x to the power n minus 1, that is 2x. Plus d square is what? It is a constant. So derivative of constant is 0. Derivative of constant is 0. Observe here. These three terms are constant and this is a function. 2cd constant. We keep the constant as it is. Derivative of x, it is 1. Derivative of x, it is 1 plus. This is over. This is over. C square x square plus d square plus 2c dx. 2c dx into, right, in the below. Derivative of ax, a into 1, because derivative of constant into function, we write as it is. Derivative of x is 1 plus derivative of b is 0. Derivative of b is 0. If you want to, once again we write, because 0 is there. One more step, if you want, we write 2c square x plus 2cd, this is over, plus c square x square plus d square plus 2cdx into a. This is very easiest method. This is very easiest method. Observe this problem carefully. Observe this method. Very interesting problem, very important problem. Next problem. Y is equal to ax plus b divided by cx plus d. Y is equal to what? Ax plus b divided by cx plus d, where a, b, c and d are constants. A, B, C, D are constant. Then which rule apply here? We apply the quotient rule. Okay. Differentiate with respect to x. Y with respect to x is dy by dx. Cx plus d whole square. Cx plus d, d by dx of ax plus b minus ax plus b into plus d. Correct? Denominator square, denominator into derivative of numerator minus numerator into derivative of what? Denominator. Okay. cx plus d whole square. Cx plus d into derivative of a into x. A is a constant. Derivative of x is 1. Constant into function plus derivative of only the constant. What? It is 0. Correct. Derivative of b constant 0. Ax plus b into same concept. Derivative of constant into function. We write the constant as it is. Derivative of x is 1. Derivative of x is 1 plus derivative of d constant. It is 0. Cx plus d whole square. Cx plus d into a minus ax plus b into c. That is enough. For me it is enough. If you want, you continue. You multiply a to these two terms and c to these two terms, simplify it and write the final answer. Here it is enough. Okay, the next problem. Y is equal to 1 plus 1 divided by x whole divided by 1 minus 1 divided by x. Y is equal to 1 plus 1 divided by x whole divided by 1 minus 1 by x. Very simple problem. See, observe it. First, before doing to differentiate, take LCM. Y is equal to x in the numerator, x plus 1. In the denominator also, x is the LCM, x minus 1. X get cancelled. This is what? The function. Y is equal to x plus 1. Very easiest method. Okay. If you want, you can differentiate directly, no problem. You know derivative of 1 by x is minus 1 by x square. If you don't know, we can solve like this. Now I write differentiate with respect to x. So which rule apply here? The quotient rule. I write here dy by dx. Denominator square x minus 1 whole square. X minus 1 into d by dx of x plus 1 minus x plus 1 into d by dx of x minus 1. Correct? d by dx of x minus 1. So x minus 1 whole square. X minus 1 into derivative of x, it is 1. Derivative of x, it is 1 plus derivative of 1 is what? Constant, so it is 0 minus x plus 1 into, again observe here, derivative of x is 1 minus derivative of 1 is what? Constant, so answer is 0. So we can continue, we simplify this one. X minus 1 whole square, 1 into x, 1 into minus 1, minus x, minus 1. Plus x minus x get cancelled, minus 2 divided by x minus 1 whole square. Minus 2 divided by x minus 1 whole square, minus x minus 1, minus 1, minus 2 divided by what? X minus 1 whole square. Okay. So if you differentiate directly, again saying derivative of 1 by x minus 1 by x square, minus 1 by x square. Next problem. y is equal to 1 divided by ax square plus bx plus c. Y is equal to 1 divided by what? Ax square plus bx plus c, where a, b, c are constants. A, B, C are constants. Which rule apply here? Better we apply quotient rule. Okay, differentiate with respect to x. Y with respect to x is dy by dx, denominator square, ax square plus bx plus c whole square, ax square plus bx plus c, d by dx of 1, correct? D by dx of 1 minus 1 into d by dx of ax square plus bx plus c, ax square plus bx plus c, that is equal to ax square plus bx plus c whole square, ax square plus bx plus c. Derivative of 1 is what? Constant. It is 0 minus 1 into, observe here 1 by 1, a constant into function. We write the constant as it is, a as it is, d by dx of x square 2x. It is in the form of x to the power n into x to the power n minus 1 plus constant into function b we write as it is, derivative of x is what? 1 plus only the constant, c is a constant, derivative of constant is 0. 0 into anything is 0, so minus 2ax plus b whole divided by ax square plus bx plus c whole square, ax square plus bx plus c whole square. Observe this problem, very interesting problem, different problem. Observe this carefully. Next one. Y is equal to ax plus b whole divided by p into x square plus q into x plus r, p into x square plus q into x plus r, where that is understood a, b, p, q and r constants. All these are all what? Constants. Okay. Differentiate with respect to x. Which rule apply here? You can also solve. Which rule apply here? Quotient rule. Yes? Okay. Y with respect to x is denominator square plus r whole square, px square plus qx plus r into d by dx of ax plus b, correct? Denominator into derivative of numerator minus d by dx of ax square plus qx plus r. This is first term. Denominator into derivative of numerator minus numerator into derivative of denominator. So we write this denominator as it is. So p x bar plus qx plus r. Observe here, constant into function. A into derivative of x is 1 plus derivative of constant is 0. Derivative of constant is 0. Constant into function. Constant right as it is. Derivative of x is 1 plus derivative of b. B is a constant. So derivative of constant is 0 minus plus b. Here it is very important. Observe here, p constant, derivative of x bar 2x, constant into function, plus here also constant into function, q as it is, derivative of x is 1, again it is in the form of constant into function, plus derivative of r, only the constant, so derivative of r is what? 0. We write one more step, okay. So px bar qx plus r whole square. So a into 1 is a into px square plus qx plus r, okay, minus ax plus b into 2px plus q. If you want, you continue multiply by a and multiply by these two terms and simplify it. For me it is enough. Okay, for me it is enough. See the problem very carefully. Next problem. Y is equal to a divided by x to the power 4 minus b divided by x square plus cos x. A divided by x to the power 4 plus minus b divided by x square plus cos x. Better first what we do, we shift x to the power 4 and x square from denominator to numerator. A into x to the power minus 4 minus b into x to the power minus 2 plus cos x. Then it is very easy to differentiate. Okay, for easy to differentiate, for that purpose only I shift x to the power 4 and x square from denominator to numerator. Okay, differentiate x. Y with respect to x, dy by dx. A constant, x to the power 4 minus 4 into x to the power minus 5, n into x to the power n minus 1, constant into function, minus b as it is, x to the power minus 2 into x to the power minus 3, minus, why I write minus, derivative of cos x is minus sin x. If you want, once again, one more step, no problem. Okay, I shift x to the power minus 5 from numerator to denominator, minus 4a divided by x to the power 5. Minus into minus plus 2b divided by, shift x to the power minus 3 from numerator to denominator, it becomes plus, minus sin x. Minus sin x. Observe this problem. Observe the problem carefully. Very simple problem. Next problem. Y is equal to 4 into root x minus 2. Y is equal to 4 into root x minus 2. Y is equal to 4 into root x minus 2. Very simple one. Differentiate with respect to x. y with respect to x is dy by dx. 4 into d by dx of root x minus d by dx of 2. d by dx of 2. 4 into root x. Okay, one step if you want. d by dx of x to the power half minus derivative constant is 0. 4 into half into x to the power half. Half minus 1. 2 2 2 into x to the power minus half. That is equal to 2 divided by x to the power half. 2 divided by root x. 2 divided by root x. Observe the simplification carefully. Observe the simplification carefully. Next problem. Y is equal to ax plus b whole to the power n. So it is very different problem. Ax plus b whole to the power n. So this function we call it as one more. So you know very well about in the second PUC class, but here problem is there. That's why I explained. This function we call it as composite function. You very well know in the second place. Composite function means what, sir? Function of a function. Composite. Function of a function we call it as composite function. So x to the power n one function, ax plus b one function. Then how to differentiate? So differentiate by using chain rule. Composite function or differentiate by using chain rule. Okay, so this concept is in second PUC. It is not in first PUC. Okay, here is problem is there. I can explain. You very well perfect about in second PUC. Once again, you know about all these things in the second PUC classes. See, observe here. Y with respect to x is dy by dx. Chain rule means one by one we link together. Firstly, we neglect ax plus b. It is in the form of what? X to the power n. Correct? N into ax plus b whole to the power n minus 1. This complete term we treated as x. Whole term we treated as what? X. It is in the which form? It is in the form of x to the power n. N into x to the power n minus 1. We are going to differentiate with respect to x. Again, we differentiate inner function. Inner function is what? Ax plus b, d by dx of what? Ax plus b. N into ax plus b whole to the power n minus 1. Constant into function. A into derivative of x is 1 plus derivative of b is 0. So what left? A into 1 is a. N a into ax plus b whole to the power n minus 1. N a into ax plus b whole to the power n minus 1. This is the method for composite function. Composite function means what, sir? You very well know in the second PUC classes. Okay, just simply you understand. Composite function means function of a function. Function of a function we call it as composite function. If you want, I can solve one more problem regarding this concept. Don't worry, you perfect in second PUC because this is in second PUC syllabus. So one more problem. Observe here, y is equal to sin to the power nx. Sin square x, no problem. Sin x into sin. But sin to the power nx, it is not possible to write up to the end terms. Then it is a composite function. Sin x is a one function, x to the power n is another function. We mix together. So x to the power n and sin x we combined together to form a sin to the power nx. That's why this function we call it as what? Composite function. Then how to differentiate, sir? Observe here. Differentiate with respect to x. Y with respect to x? dy by dx. Firstly, this complete term we treated as x to the power n. X to the power n differentiation, you know, n into x to the power n minus 1. N into, in place of x is what? Sin x to the power n minus 1. Sin x to the power n minus 1. Then differentiation of composite function, sin power, another function, d by dx of sin x. N into sin x to the power n minus 1. Derivative of sin x is cos x. Derivative of sin x is cos x. Observe this problem. Derivative of sin x is cos x. Okay, this is the method. So you very well know in the second PUC classes for this composite function. Up to this, we finish up the chapter limits and derivative completed. So better you perfect all the concepts of limit and derivatives. It is very important chapter in both first PUC and second PUC. Thank you.